Our topic for today is about earthquakes, unveiling the focus and epicenter, a clear, visual guide to the two fundamental locations that define where an earthquake begins and where we feel it on the surface. The Earth's tremors. Where do they start? Imagine the Earth's crust as a giant, fractured puzzle of tectonic plates. First, let's talk about hypocenter, the Earth's inner tremors. What is the focus? The focus, also known as the hypocenter, is the exact point within the Earth where an earthquake rupture begins. It's the initial release point of seismic energy, the birthplace of seismic waves that radiate outward through rock and mantle. Its location is underground, where it can be a few kilometers to hundreds of kilometers deep. For its role, it is a source of seismic waves and fault slip initiation. Depth matters. Shallow foci produce stronger surface shaking, while deep foci spread energy over larger areas. Next, the epicenter, the surface connection. Epicenter location alone doesn't indicate intensity everywhere. Local site effects and rupture propagation can shift peak shaking away from the epicenter. The epicenter is the map point on Earth's surface that lies directly above the focus. It's given as geographic coordinates and is the label reporters and hazard maps use after an event. While frequently associated with the strongest shaking, the epicenter is only the surface projection, and actual damage patterns depend on depth, local geology, and rupture directivity. Next, visualizing the relationship. The focus is below ground, while the epicenter sits on the surface directly above it. Seismic waves radiate from the focus in all directions, arriving at the epicenter first on the surface but spreading outward to affect wider areas. Seismic wave types. P waves arrive first, also known as compressional, then S waves, also known as shear, slower but often more destructive surface waves. Earthquakes in the Philippines, a tectonic hotspot. The Philippines sits on the Pacific Ring of Fire where multiple plates converge, such as the Philippine Sea Plate and the Eurasian Plate. This complex boundary network produces frequent earthquakes with a wide range of focal depths and epicenter locations. Frequent events. Many small quakes daily and occasional large events with significant impacts. Multiple fault systems. Subduction zones, strike slip faults, and offshore sources create varied seismic behavior. We have here the three types of faults. First, the shallow. It is the most common and generally the most destructive at the surface because seismic waves lose less energy before arrival. Second, the intermediate. Reduced surface intensity can still cause significant shaking depending on magnitude impact effects. And last, the deep fault. Seismic waves travel farther and attenuate more, less surface damage despite potentially large magnitude. This diagram summarizes how an earthquake begins at the focus, how seismic waves travel, and how the epicenter is the surface point that first received those waves. Wave type and travel distance determine perceived shaking and damage patterns. For the key takeaways and conclusion, the focus is a subterranean origin of seismic energy, while the epicenter is the surface point directly above it. Depth determines how energy reaches communities. Shallow foci often cause intense local damage, while deeper foci produces wider but milder shaking. Applying these concepts improves hazard assessment, emergency response, and public preparedness, critical in the Philippines' active tectonic setting. Practical tip. Emergency plans should account for both epicenter location and focal depth when estimating the impact zones. Community action, added early warning systems, and building codes can save lives of the people. Together, they tell the full story of an earthquake's origin. The focus explains why and how rupture began, while the epicenter gives responders and the public a clear location on the map. Both are essential for accurate hazard assessment, early warning, and resilient response planning.